When planning enterprise AI deployments, executives picture clean, perfectly mapped processes in quiet rooms. But this environment is where those tools actually have to survive. At the frontline, work is constantly interrupted, highly improvised, and governed by a ticking clock. A technician repairing a critical asset operates under extreme physical and time pressure, making decisions based on incomplete information. This linear chart represents the official process. The technician arrives on site to fix it. The official corporate diagnostic app requires 12 separate screen taps to load the initial fault tree. With the financial clock ticking, the technician ignores the application entirely, pulls out their phone, and texts a senior peer to get an immediate answer. To evaluate workarounds, we use a diagnostic decision tree. First, we ask, why did the worker abandon the process and what was gained? Then, we map consequences, identifying systemic risks like zero audit trails and the underlying system failure that forced the technician's hand. That system failure is almost always an issue of cognitive load. This is the mental friction generated when enterprise software demands intense focus and complex navigation during a crisis, exactly when a technician has the least amount of time to give it. Frontline deviations are rarely acts of defiance. They are highly intelligent human adaptations to software that completely ignores the physical realities of the job. This matrix categorizes field behaviors. A useful adaptation occurs when an operator bypasses a clunky terminal to physically verify a jammed gear, saving time. Conversely, avoidable waste happens when that operator must manually enter the exact same data into 3 different systems. And then we have a dangerous workaround. You see this when an IT support technician executes a fast, undocumented desk-side fix to help a frustrated user, but never officially logs the ticket. Because the ticket is missing, the system develops a permanent data blind spot. You cannot train an AI model on solutions the system never recorded. Identifying these blind spots provides the most urgent redesign opportunities for future automation. By sorting behaviors into these categories, leadership can stop penalizing workers for adapting to bad software and focus entirely on eliminating the friction points that actively block AI adoption. The only reliable way to map that friction is through the day in the life of observation method. You step away from the whiteboard, follow the technicians into the field, and silently document every physical workaround without correcting their behavior. We analyze observations using the debt delta scorecard. Comparing official procedures against the massive actual steps executed reveals the organization's process debt. We push this bloated workflow through a 4-step sieve, eliminate zero-value steps, automate entries, collapse forms, and guide the worker. That streamlined process is the bedrock of intelligent operations. Instead of forcing a worker to hunt through complex menus, the AI pushes context-aware guidance directly to their device, allowing them to confirm a repair sequence with a single tap. This interaction establishes a trust loop. The AI reduces cognitive load, the technician validates in real time, and the system learns. To make these technologies work at the edge, organizations have to stop layering AI on top of broken systems. The workflow itself must be redesigned until the intelligence acts as invisible, trusted infrastructure.
For more insights, subscribe to Purposeful Nudge and start rewiring your field services organization today.